When we imagine the prehistoric world, our minds are inevitably drawn to the sauropods. These long-necked leviathans, dominating every continent during the Mesozoic, were biological skyscrapers that defy modern comprehension. With some weighing over 80 tons and stretching longer than 30 meters, they were the undisputed kings of size. A single titanosaur could equal the mass of 7 African bush elephants stacked back to back. Because they were so impossibly large, they tend to monopolize the conversation regarding megafauna, casting such a long shadow that we rarely stop to consider what stood in second place. If we remove these long-necked giants from the equation, a fascinating question emerges. What was the largest animal to walk the earth that was not a sauropod? Intuition might point toward the famous predators. Logic dictates that to hunt giants, one must be a giant, and the theropods certainly tried. The Tyrannosaurus rex pushed the biological boundaries of a bipedal carnivore, with exceptional specimens breaking the 10-ton mark. Yet, in the grand competition for mass, the T-Rex was not the title holder. The true answer is not found in the Badlands of North America, nor does it belong to a sharp-toothed hunter. Instead, the champion is a dinosaur that many have likely never heard of. It was a gentle vegetarian found in the Late Cretaceous of China, a creature named Shantungosaurus. The story of this colossal creature began in 1973 within the Guangxi Group on the Shandong Peninsula, a geological formation that would prove to be one of the richest fossil beds in the world. Researchers stumbled upon a field containing the remains of 5 distinct individuals. From the moment the first bones were unearthed, it was apparent they were dealing with something extraordinary. The skeletons were scattered and incomplete, yet the sheer scale of the individual bones sent shockwaves through the excavation team. The bones were so massive that the initial reaction was to assume they belonged to a sauropod. However, as the anatomy became clearer, the shape of the limbs told a different story. These were not the pillar-like legs of a long neck, but the distinctive limbs of a hadrosaur, or duck-billed dinosaur. This was a startling revelation. Hadrosaurs were generally viewed as the cows of the Cretaceous, widespread, herd-dwelling herbivores of respectable but rarely record-breaking size. The discovery of Shantungosaurus shattered that perception. It bore a striking physical resemblance to the Edmontosaurus, a famous North American hadrosaur known for its size. Today, Shantungosaurus is considered a close relative of the Edmontosaurus, sharing unique traits such as distinct skeletal structures and specialized dental arrangements. However, the comparison yielded a shocking conclusion. Edmontosaurus was big, but Shantungosaurus was titanic. To truly appreciate the absurdity of this animal, we must look at the raw data. One of the smallest known specimens recovered, likely a juvenile, possessed a femur equivalent in size to that of a fully grown modern elephant. And that was merely the starting point. The holotype specimen measured nearly 15 meters in length and weighed over 13 tons. To visualize this, imagine an animal 7 times heavier than the average mid-sized sedan. Yet, even this was not the limit. The largest individuals are estimated to have reached lengths of up to 17 meters, or roughly 56 feet. In terms of weight, these elders may have tipped the scales at anywhere between 16 and 18 tons. There are even more liberal estimates within the scientific community suggesting weights ranging from 19 to 22 tons. While these higher numbers are subject to debate, even the conservative estimates are staggering. At the lower end of the scale, this animal was heavier than every single theropod dinosaur known to science, outweighing both Spinosaurus and Tyrannosaurus rex. At this size, Shantungosaurus completely outclassed any other ornithischian dinosaur ever discovered. The group containing icons like Triceratops and Stegosaurus. This duck-billed giant was over 3 times the size of a Stegosaurus and double the size of the Ankylosaurus. It was roughly 40% larger than the maximum size of a Triceratops. If you were to construct a scale made of living humans, it would take approximately 260 average-sized people to balance out the weight of a single Shantungosaurus. Perhaps the most impressive metric is that the largest known Shantungosaurus femur is comparable to the femurs of the largest sauropods, because paleontologists believe hadrosaurs were facultative bipeds, capable of walking on 4 legs but rearing up on 2. Shantungosaurus holds the prestigious title of being the largest bipedal animal to have ever lived. The anomaly of Shantungosaurus becomes clearer when compared to the largest land mammals that followed millions of years later. Throughout the Cenozoic era, only 2 terrestrial giants offer a valid comparison: the Paleoloxodon pneumaticus, a straight-tusked elephant, and the Paraceratherium, a giant hornless rhinoceros. Both of these mammalian titans have maximum weight estimates similar to the upper limits of Shantungosaurus. However, the consensus is that on average, the dinosaur was likely heavier and definitively longer. This gives Shantungosaurus a strong claim to the title of the largest non-sauropod land animal in history. What makes this narrative even more compelling is that extreme size appears to have been the standard for this species. The excavation of over 50 different specimens suggests that each adult was well over 10 tons, implying we may not have even found the true giants of the species yet. Why did Shantungosaurus evolve to be so enormous? While the precise evolutionary pressures are lost to time, the prevailing theory is that size was an adaptation for defense and resource accessibility. Being a giant allowed it to reach high foliage, but more importantly, it acted as a deterrent against predation. In Cretaceous China, Shantungosaurus shared its world with a massive predator known as Zhuchengtyrannus. This was a tyrannosaur, a close relative of the T-Rex and the apex predator of the region. However, the power dynamic here was heavily skewed. Zhuchengtyrannus was large, but its adults hovered around 5 tons. While terrifying, this predator was only about 1/3 the weight of a fully grown Shantungosaurus. This disparity changes our understanding of the predator-prey relationship. While the tyrannosaur may have hunted juveniles, attacking a healthy adult Shantungosaurus would have been a suicidal decision. It is rare in nature for the largest animal in an ecosystem to be a hadrosaur rather than a sauropod. This size advantage ensured that adults were virtually untouchable. But size was not their only defense. Shantungosaurus possessed an impressive array of capabilities that made it a nightmare for attackers. First, consider the physics of a collision. If a 15-ton animal ran into a predator at top speed, the kinetic energy transfer would be immense. Calculations suggest that being hit by a charging Shantungosaurus would pack more energy than the combined punches of over 1,000 professional boxers. It would be akin to being struck by a runaway locomotive. Even a glancing blow from such a massive creature would shatter bones and rupture organs instantly, leaving a predator incapacitated before the fight even truly began. Interestingly, standing in front of a charging Shantungosaurus might have been safer than standing behind one. Recent paleontological research suggests hadrosaurs were capable kickers. Their massive hind limbs could be weaponized to obliterate an attacker. A single kick involved a limb roughly the same size as the predator's entire body. Furthermore, there is support for the idea that they could wield their tails as weapons. The tail of Shantungosaurus was longer than 2 cars and composed of heavily ossified tendons. These tendons hardened into bone-like structures, turning the tail into a rigid club. By swinging its massive hips, the dinosaur could bludgeon any predator approaching from the rear. A predator stalking a Shantungosaurus also had to contend with the fact that these animals lived in large herds. This social structure made predation significantly harder, as there were always many eyes watching for danger. Communication played a vital role in this defense. Research into the skull anatomy has identified large openings near the nostrils. In life, these were likely covered by loose flaps of skin that could be inflated to create loud, resonating sounds. This animal could not only physically defend itself, but could also broadcast warnings over long distances. Additionally, its general bone structure was incredibly robust. So far, there is no evidence that Zhuchengtyrannus hunted in packs to overcome these defenses. Faced with a herd of communicating, tail-swinging giants, local predators likely focused on easier targets. Despite its intimidating arsenal, Shantungosaurus was a strict vegetarian. However, feeding such a massive body required an incredibly efficient processing system. This brings us to the dental batteries of hadrosaurs. A single Shantungosaurus had over 1,500 tiny teeth packed into its jaws. These were arranged in complex columns that continually replaced themselves. As surface teeth wore down from grinding tough vegetation, new teeth pushed up to take their place, creating a conveyor belt of dental power. This allowed them to process large amounts of fibrous plant tissue that other herbivores might struggle to digest. Complementing these teeth was a huge beak designed to shear foliage with ruthless efficiency. When combining this appetite with their massive size and herd behavior, the animal acted as a powerful ecosystem engineer, much like modern elephants, which dramatically reduce vegetation density. A herd of 50 Shantungosaurus would have cleared pathways and knocked down trees, altering the environment for other species. The world that Shantungosaurus shaped was the Guangxi Group, a geological formation representing a vast floodplain with a warm, humid climate. It was a lush world dominated by cycads, ginkgos, conifers, and ferns. This abundance of food supported one of the most diverse dinosaur populations known to science. The area holds the record for the highest density of dinosaur fossils of any known formation. The giant Hadrosaur shared its home with a colorful cast, including the horned Sinoceratops, the armored Pinacosaurus, and the giant sauropod Zhuchengtyrannus, which ironically might have been smaller than the Shantungosaurus itself. The fossil record also preserves fish, turtles, and crocodilians, painting a picture of a wetland ecosystem teeming with activity. Despite its dominance, Shantungosaurus appears to have been geographically restricted. While other hadrosaurs spread across continents, this giant is only known from the Guangxi Group area. Some paleontologists hypothesize that its size came at a cost. Being so large meant astronomical caloric requirements, and few environments could support such a dense concentration of biomass. The lush floodplains of Shandong may have been a unique zone that provided enough food to sustain them. Nevertheless, the species found great success, surviving for over 10 million years before vanishing. The cause of their extinction remains a subject of inquiry. There are several theories. The first is that the energy required to keep a 20-ton body alive became sustainable. If the environment shifted, perhaps a climate change that reduced vegetation density, the region could no longer support such large herds. they would have been the first to starve. A second theory points to geological violence. Parts of the formation contain evidence of lava flows and pyroclastic deposits, indicating volcanic activity. A local extinction event caused by eruptions could have wiped out the population. A final idea is that the lineage simply evolved, transitioning into smaller forms as environmental pressures shifted. Regardless of how they met their end, the legacy of Shantungosaurus is secure. It challenges our assumptions that the only path to gigantism was the long-necked body plan. Here was an animal that took the standard duck-billed design and pushed it to the absolute limit of biological engineering. It serves as a poignant reminder that the fossil record is still full of surprises. While the T-Rex and Brachiosaurus adorn the covers of textbooks, animals like Shantungosaurus wait in the rock, ready to rewrite the rulebooks of biology. Its existence proves that nature's capacity for creating giants was far more diverse and experimental than we often dare to imagine. No hadrosaur would ever again reach such massive proportions, and it is presumed that no other non-sauropod land animal has matched its size since. It was a singular moment in time when a vegetarian biped grew to the size of a tank and looked down upon the tyrannosaurs. In the Great Hall of Earth's history, Shantungosaurus stands not just as a footnote, but as the true heavyweight champion of its kind.